Now that we know how to add, update, and delete information from the database, let's look at how we can query it. Querying a database is similar to asking questions about our data. To ask questions to the database, we use the select statement. The main keywords implied here are select, from, where, join, order by, group by, and having. We can read it as select some columns, from some tables, where some condition applies. In that sense, it's quite close to natural language. We can specify how two tables are linked together using the join clause and specifying on which columns they are linked. As we mentioned earlier in the tutorial, items in the tables are unordered. In this case, the order by clause will be used to sort the results of our query. The group by clause is used to agglomerate the results by category. For example, we could group our students by program. Finally, historically, the where clause could not be used with aggregate functions, which we'll see later. The having clause was added to SQL to fill this requirement. For the following examples, we will be using the toy database from MySQL. This database represents employees as part of a company. More information about the schema can be found on the MySQL website, and the data can be downloaded from GitHub. The database comprises 6 tables, from which 3 are shown here. On the left, we have the main employees table. On the right, we have the departments table. And finally, in the middle, the table department employees, or dept.emp, is used to define to which department an employee is linked. And so I've included the employees database within MySQL Workbench, which we can see here. We can see the different tables from this database and then the different columns as we were doing previously. And so just to make a simple query here, I'm just going to select the employee number, the birth date, the first and last name, the gender of the employee, and the hire date. And so I'm just going to select all of this from the employee table. And so if we looked at the employee table, we can see that we have these columns here. So if I run this query, I now retrieve an actual result. And so these are all the employees from the table. So they all have a specific hire date, a gender, and so on. So we can see from the results here that we got 1,000 row. By default, MySQL Workbench actually limits to 1,000 row, which you can increase if you want. This is mostly for speed purposes, if you have a very big database. And so these are all the results that were returned using this simple query. Similarly, actually, if we wanted to not specify the columns, because in this case we're actually getting all the columns, we could just replace all of these with a star, which would mean that we're going to select all the columns from the employees table. So if I run this, again, I've got exactly the same result. So this was a pretty simple query. Let's increase the complexity a little bit. And so we can actually select all the employees that would be of gender F, or female employees in this case. So in this case, we would just specify that we want the gender column to be F or equals to F. And if we try that, we can now see that all the employees that were returned are actually female employees. So we can go one step further. In this case, this was a fairly simple where clause where we only have one condition. In this case, one column needs to be a specific value. We can actually use logic to make some more complex conditions. So for example, using AND or. So in this case here, I'm going to do a query where I want to have all the female employees, and their hiring date needs to be prior to 1988, the 1st of January, or the 1st January of 1988. And so if I run this query, I now retrieve indeed female employees that were hired before 1988. Similarly, we could simply look for a specific name. So if we want to look for, in this case, female employees called Gao, so their first name is Gao, we simply do it like this. So if I run this query, I now retrieved female employees for which the first name is Gao. If actually what we wanted was to have people with the first name not necessarily with a fixed value like this here, which is Gao, so everyone is called Gao, but we would like instead having employees for which the first name starts with a J or a G, let's say. We could do that like this. And so in this case, we replace the equal sign by like. And then, because we want to start with a G, we can then put the percentage sign to mean that we want anything that is following this value here. And so now we're going to have female employees for which the first name starts with a G. So if I actually run this query, indeed I got now different names, and they all start with the G. We can do the same trick if we want to have any name for which G is part of the string. And so I could do it like this. And now I get any name for which the name includes a G. Similarly, if we wanted to look at employees for which the birth date is between a specific range, we could do it like this. And so we have our joint conditions here with our end. And so now we want to have employees that were born between 1963 and 1964. The 1st of January of each year. So in this case, the birth date here would be equal or greater or equal to 1963. So in this case, the 1st of January is actually included in our query, and then the birth date here, smaller than 1964, 1st of January, would be excluded. And so we would have everything within the 1963 year, but nothing from the 1964 year. So if I run this query here, and I look at the birth date, we can see that everything is within 1963. Furthermore, because here now all the dates are randomly assigned, we cannot really see any order within the dates. If we wanted to actually order them or sort them, we could do that by typing order by, and then birthday, birth date in this case. So if I do that now, my result has been sorted. And so now we have, first of all, the January, and then it goes on. Similarly, we could add desk to mean that it's descendant. And now it starts with the December dates. And so by default, it's ascending dates or ascending order, and then if we want to change it, we can say in descending. So far, we only queried data from a single table. If we want to get information about two tables, for example, we can use the join statement as we mentioned earlier. While different joins exist, the most common is the inner join. Thinking again about our tables as different sets, as in set theory, the inner join represents the union between two or more sets. Back to MySQL Workbench, we're going to look at a simple inner join where we want to link the employees table with the salaries table. We are going to specify that these two tables are connected with the employee number. So we can see here that both the employee table has the employee number and the salaries table. And so in this case, we're saying that both these numbers are the same in both tables. And because we don't want to have the information about all the employees, we're going to restrict it to a specific employee with the ID or the employee number 10,001. And in this case, we're going to retrieve all the columns from both tables with the star here. So if I run this query, and now retrieve all the information about the employee 10,001, so we can see that his name is Georgie Facello, his birth date is from 1953, and so on. And we can see the salary that he's made over a couple of years. We mentioned previously aggregate functions while talking about the having clause. SQL indeed includes functions to aggregate results from a query. Notable examples are count, sum, and average. Getting back to our previous example, we can see that Georgi Facello made quite a bit of money over the years. If we were interested in knowing how much he made throughout the course of his career, we could actually just sum over the salary column here. So I prepared a query here where I modified slightly the query where I'm now retrieving only a few pieces of information. So the employee number, the first and last name, and then the sum of all salaries. We can note a few things here. So here I'm actually mentioning from which table I want to plot the information. So I want the employee number from the employees table. It's the same in both tables, but the database doesn't necessarily know that, so we need to specify. The first and last name will also come from the employees table, and then the salary comes from the salaries table. And then the rest is exactly the same as previously. So if I run this query, and I'll retrieve the total sum that Georgi made during his career in this company, which would be over $1 million in this case. Another example of aggregate functions is the count, as we saw before. And so let's say I was interested in knowing how many male employees are employed within this company. I could simply count all the columns from the employees table where the gender is M. And so if I do that, I now know that there is over 100,000 employees that are male in this case. Let's see how many females there are. And these are a bit less. So the parity in this company is not as good. As a final example for our aggregate functions, let's have a look at how many employees are part of each department. So in this case, we're going to look at the department employee table, as we saw in the previous slide. And we're going to join this table to the departments table, where the department number is the same in both tables. Here we can see that we can actually shorten the name of our departments using aliases. And so, for example, here department employee is now callable as DE. So I can just type DE and I'm going to refer to this table. So here during my link I just type DE. And so we're going to group the results by department name. And here I'm going to plot the department name from the departments table and the count of all the results. So if I do that, I now get a list of the departments and the number of employees per department.